Hello everyone and welcome to this session of Exam Helper 7th semester Cryptography and Network Security videos series. So this time I have decided to explain each and every topic on the whiteboard, like in the entire big board instead of using the small board or the monitor. I'll also be providing the dictation notes or the handwritten notes in the link. This time I'll be preparing everything in an organized manner. So let us start with our first topic, that is nothing but the model of network security. So the plan of making videos for this subject, I'm planning to make each topic one by one by grouping them. So for module 1 there will be a set of 15 videos. So I'm trying to cover each and every topic fast. So if you have any problem you can just tell me, I'll be completing that according to the pace. So we have also provided the monetization, membership. So in that I'll be explaining each and every topic in detail using this photo. So for everyone it will be that it's just 60 rupees per month. You can take it while you want for exam time. Once you see it, you can again leave it off. So let us start understanding what is network security model. So before we start understand anything, I would like to present a small image type explanation. Suppose there is a person A, that is Alice or Alexander, anyone, your friend A, and there is a person B. So imagine this both are a lover, like olden times. If we dive back into the 90s, so this male guy, let us keep M and F, right? It will be more easy to understand. Male and female. He writes a love letter, and he wants to pass this letter to this female. This is the letter. So how is he sending? He is sending through a postman, and this postman is nothing but the third person party. Okay. If it is a modern time, he will send it through SMS. It is a modern timing SMS, or he will send through a trusted third party. Okay. So now there is another boy. Okay. Let me call him as M2. This guy also likes this girl. You know what he tries to do? Instead of, he tries to alter this letter. If it is passing through postman, what he might do, he might distract this postman and slowly swap the letters, which this letter belongs to M, okay, the male, but he might swap it and give his letter instead. So this is the type of problem which we face. So this guy is the opponent which we have over here. F is the recipient or the receiver, M is the sender. So basically what happens, this is the entire first topic. So this is the diagram. If you ignore this red area, so above this is a diagram. You don't have to consider this. So what consists in this diagram? We have a message. This is the original message. So I write original message in the short form so that you understand. Then at this part is nothing but a security related transformation. It's nothing but a process or an algorithm which converts this original message into a cipher text. So suppose this hello, HELLO, it can be converted into something like ME#7P, like that, something. So there are particular models or methods for cipher text. So if you see here, which consists of original message, a security transformation, and secret info is nothing but a key. Okay, I'll draw a key over here. It doesn't look like a key, but still. And then here is the secret message. So what happens? Original message is transformed into a cipher text or a secure message by using this security transformation, which is nothing but consists of algorithms. Here are those things. Okay, we'll study step by step. Secret is key. So here the lock happens. The key is also, we are using this key. Now it is passed to the information channel. While traveling through this information channel, here is the main context where the opponent tries to attack. The opponent can be a software like a virus, Trojan horse, or a malware, or a human hacker who is trying to read your messages or copy the data, or do some changes or like that. And here you have a third party as well. Third party, role of third party is nothing but if you want to see how the postman was here, it's trusted guy. So it either handles the distribution of keys. You have these keys, right? He will lock, give the key to the third party, and he will give to the recipient, or arbitrary disputes. In the sense, sometimes if you have to confirm the legitimacy or authenticity of a page or a content. So this arbitrary dispute, it provides the authenticity of something. For example, if you have a certificate and that has been passed to it, how to know whether if it is a legitimate certificate? This trusted third party provides a authenticity, like it provides a proof that it is legitimate. So that is the two roles of third party. Then from once it passes the information channel at the receiver side, this whole is the sender side, this whole is the receiver side. Here the secure message is received. Again it undergoes the security related transformation. Whatever happens here, the backward happens here. So here the original message is converted to a ciphertext. Here the ciphertext is received, that is transformed back to the original message. Key secret info is nothing but the key is provided back to unlock this lock, and the original message is read by the recipient. So basically what is happening, the original message is converted into a secret message using a secret info and some algorithm. The secure message passed to the information channel received by the recipient. The security key can be delivered via a trusted third party or manually from A to B. Then the opponent might attack it by a human or a software. Here the ciphertext is received. Same ciphertext is again undergone the process decryption. So here encryption has happened, here decryption. Main thing you want to know about this is encryption. Using the secret info, you unlock this message, the recipient read. So once you finish this, understand this explanation, you can easily explain them by sending the sender. What is one? You see sender, you have security with the transmission 2. In this thing you can talk again about encryption, what happens at the sender side, what happens at the recipient side. Same way, secret information, what happens at the sender side, receiver side. It is nothing but the secret key providing by using any cryptographic means or by other means. You have KDC, you see I have written over here, see 1, 2, 3, okay. Information channel where the actual secret message is transferred, like the path where the message is traveling and where it is exposed to any external threats. Then again same thing, right? Secure message, what is the secure message? After the encryption and the secret key is passed, the secure message. So secure message, information channel you have to talk separately, trusted third party, then this opponent, that's it, right? Yeah, and the receiver. Okay, 8. So 8 things you have to talk, and that completes this diagram. After that you have to know about the 4 fundamental tasks. So here you can see that designing the algorithm, in the sense what? Designing the security related transformation, which algorithm to use. AES algorithm, encryption algorithm. This is the encryption algorithm. Just an example, SHA-256 is an hash key function, RSA public key generation. So all these things is nothing but you have to design the algorithm in such a way that it's very difficult for the opponent to decode or crack it. Generate secret information. The secret key which you are generating should be very random. See, it has to be very random. It has to be long in the sense 128 bit or above, and then it has to be truly secret, like you shouldn't share to anyone except with the trusted third party, or share within 2 people themselves, like manually. Distribution and sharing of secrets, the key. So what the third party does, distribution of key. The trusted third party, okay, either he does the distribution of the key, or else you have this KDC, key distribution center, which you will be learning completely as a separate topic in the further modules. And then you have public key cryptography. So in the sense you are using cryptography techniques to deliver this public key. So this completes, the diagram is done, 4 fundamental tasks is done. You have to remember this. Okay, so we have what is specify the protocol, when the encryption should happen, what kind of technique or algorithm you have to use, how to use it. It's basically that. If you have to understand the protocols, like I'll say a request for a secure channel to communicate with V. So what happens, this KDC provides a secure session key in which A can write a message and send it. So this will be a secret message, it gets transformed and delivers to B. for you to understand in a better way, let us keep the dark humor as and understand, like suppose two people are there, you book a room in a hotel. So now this room is nothing but a session key, okay? Then you know who comes in the hotel usually, this room service guy. So this room service guy can be a trusted third party, or it can be an opponent who's trying to attack you, okay? So who is trying to disturb your privacy. So to get privacy, you have booked the room, right? So that's nothing but a session key where actual communication is happening. It's not necessarily that both are present at the same time. The one person, a boy, goes alone, books it, secures the room. That is the session key. Now this room number should be provided to the another person who is waiting, might be waiting down or at the home, coming to that particular hotel. So the room number and the hotel name is nothing but the private information or the secret information should be provided to the other person. So that's how you try to pass it through the room service guy securely. Bro, can you just pass the information like this? No one else should know. Should be trusted third person, and or else you have to call and provide without any third person is listening to your call. You have to call and tell. So this is one basic idea of protocol. When to encrypt, what secret key should be used, how to do it, etc., etc. Once you complete this, you also have another diagram in your textbook. See here, this is about network security. Another way of securing. So here you have the opponent, this information channel or access channel, human and software. Human, like I said, software. See, if I talk about software, it can be any malware or a Trojan horse, etc., etc., virus like that. Human can be a hacker like that. So this guy is nothing but a gatekeeper. So whoever is trying to access this information system, he has to pass to the gatekeeper. What is it, gatekeeper? If you try to access a web page or an account, you have to log in. This login page is nothing but a gatekeeper. Okay. So here only the verified users can pass. For example, using your unique username and password, you can pass. If it detects any anomaly, see here, if activity monitor keeps on, we'll talk about that afterwards. So this guy will keep on checking. Whoever seems doubt, like, array, this guy looks like a problem, he just throws it out, does not allow the entry. Okay. So access channel is nothing but the path to access the information system. What does the information system consist of? Computing resources. What are the computing resources? It is nothing but the processor, nothing but CPU, memory, that is nothing but the RAM, input, output, okay, resources. Then it is what assets that does the information system contain. It contains the data, processors and software. These three are nothing but assets. There are two ways of providing the security. One is the gatekeeper and another is the internal security control. Like I said, gatekeeper, it only allows the verified users to come inside, and if there are any malicious or some type of abnormal behavior detected by the user, it does not allow the entry. Else, apart from that, what internal security control, what it does, activity monitor, it keeps on checking the activity of the user. Sometimes what happens, my credentials might be leaked and someone used my username password tries to enter. So that activity is being monitored, what he is trying to do. Sometimes even though if my Google, if you give a password to someone, email password, it still sends a security alert that it was logged in. Was it you or not? Please confirm. So that is one activity monitor. Anomaly detection. When any type of anomaly, like continuously typing the wrong password, okay, a notification will be sent where you're trying to log into your account. Log analysis, intrusion detection system. This is IDS. It tries to detect whether a person has secret, like from the back door, entered from the back door or not. This is one of the cyber security things. If you just remember the heading, you can easily explain. Then there are two ways of security measures. Same way, there are two types of threats. One is the information access threat and the service threat. Okay, CEVIS. Okay. In information access threat, what happens? Intercept, modify, and exfiltrate. Okay, so intercept in the sense what? You will try to log into your account, maliciously trying to access the data, reading your files, everything, personal messages. Modify, changing the data, deleting of the data, etc. like that. Exfiltrate is nothing but you try to same way, like how instead of modifying is changing. In exfiltrate, you change the data, changing the content, locking it, or maliciously deleting. In the service state, you have denial of service. Okay, so no matter what you try to do in your system, you won't be getting the access. Resource exhaustion. It will exhaust your CPU in such a way that your CPU won't be able to handle task. Then you have ransomware. It will lock your files and ask money from you. Until you pay the money, it won't unlock the files. So these are all the things you want to know about the first topic. I know it was kind of lengthy, but from the next topic I'll try to make it short. I hope you like this. And again, I forgot to tell one main important point at the beginning of the video, that you people don't subscribe or like. Anyhow, it's the end of the topic, so most of you won't even be seeing this point of video. But still, if you have not what to say uh, liked or subscribed, kindly do it, man. I waste a lot of, not waste, I invest a lot of time for explaining. I can easily, even I'm a student like you, I have the examinations coming up, I'm preparing for my examinations, but instead of preparing by myself, which saves a lot of time, I'm investing and explaining you also. I deserve a like and subscribe. Kindly do it. We'll see in the next topic, and also put some suggestions what I can do to explain properly.